Um, so there's only two of you here, which is kind of surprising. I thought there'd be at least a dozen between three sections of this class. I thought there'd be at least a dozen. Maybe it's just a bad time on a Friday. I don't know.
Well, when classes were still in person, did you do the like a final review class or?
Yeah, I did.
And I'm guessing more people showed up.
Not as many as you might think. If there's a class of 20 students, maybe three show up. Four.
Wow.
Sometimes what I do just to piss them off is I'll give the people who showed up extra credit. Then on the day of the final, I said, all right, those of you who showed up to my review, don't forget to add 5 points on your final exam. Everyone's like, what? I'm like, yep. Those of you that showed up got 5 points. And they're like, I would have came if I knew that. I'm like, well, you should have came anyway.
Right.
I mean, I did not anticipate this.
You think it'll be more students just for the simple fact of you want to make sure you do good on the test.
Yeah. Um, I did not anticipate this. Only two of you. Between three sections, there's only two of you.
Wow.
Well, I mean, while you're here, you can ask me whatever you want.
Um, I think chapters 2 and 3 is what gets me.
Okay. Any problems on the review sheet? Or I'll go over anything you want on the review sheet. Or if you have any specific questions, just tell me what it is and we could look at them.
So, because when I was doing the chapter here, actually, let me pull up the homework. Chapter 2 homework.
Okay.
Um, like I started understanding it as I did it, but just to make sure that I understand it. Um, it's actually,
You have a specific question?
yeah. Should I screen share it or?
Yeah, you can do that. Yeah.
All right, I'll open up because I have it open on my
Yep.
other computer.
Sure.
I'll just open it up on my laptop.
I'm shocked. I'm shocked.
I am too. I thought I thought it'd be like a lot of people.
Thought there'd be more than two.
Yeah.
Between three sections. Jeez.
I'm trying to screen share and it's saying that the host disabled screen sharing.
Really?
Mm-hmm.
Hmm.
I don't know if you're able to enable it.
Yeah, I should be able to. I don't know why I can't. Can't. Usually there's a button here where I can press to let me do it, and it's not here.
Yeah.
I don't know why. Let's go there. I don't know why it's not letting me share it. Let you share it, Brendan.
Um.
Are you on Zoom on your laptop?
Yes.
All right, let me see. Oh, I cannot. I think I know why. Because I'm recording this.
Oh, gotcha.
I can't record things if you share your screen. I think
Gotcha.
that's why it won't let me. It won't let you share.
Mm-hmm. Gotcha.
So what is the question?
So um, so with chapter 2, the word problems, um, and with the graph and all that, it's saying so with with um with the variables that we use. So in this problem, it's saying t and n. Um, it's the same thing as x and y, but just with a different letter. Correct?
Oh, man, it's really hard. I can't see what you're looking at.
Um,
Do you know the? Is it in a textbook? Is it where is it?
it's um, it's section 2.1 of the homework
In the textbook or in my math lab?
in my math lab.
All right. I don't know why. Let me log in to
Yep.
my math lab. It takes some time. Are you talking? Have you looked at the review packet, Brendan?
I just accessed it when I joined in because remember I was saying that I wasn't able to find it.
Mm-hmm.
Yeah, and then you told
So,
me.
is the question you're referring to perhaps like question number 7?
Yes. Yes.
So I don't have to open my web browser because it's being really slow.
Okay.
Because when I'm recording a live review session on Zoom, my internet gets like my computer like bogs down. I
Yeah.
can't do this and then go on the internet at the same time.
Yeah.
So it looks like this, right?
Yep.
Okay. So is this the question you want me to do?
Sure.
All right. So what do I do here? I have data, right?
Yep.
So the percentage of U.S. teenagers with a driver's licenses are shown in the table below. All right. We're letting P equals F of A be the percentage of teenagers at age 8 years who have a driver's license.
Right.
So this right here is the age data. That's the A data. This right here is the percentage data. My independent variable is age. My dependent variable is percentage. So question A, find the equation by hand. Now, how do you find an equation of a line? This is linear model. All right, this is a linear model. So how do you find the equation of a linear model? By hand, anyway. In order to make a linear equation, you need what?
You need it's would it be y equals mx plus b or
So yeah, you need a slope.
yeah.
And you need a, if you use y equals mx plus b, or you use point slope form,
Yeah.
you'll need the y-intercept or a ordered pair. I use point slope form.
Okay.
So you need two ordered pairs, basically.
Yeah.
Right. Now, which two ordered pairs am I going to pick out of this? So there's 5 ordered pairs in this data. So which two am I going to pick?
Would be the first one. You picked the first and the last one?
So what made you choose that?
Not really sure.
What made you choose the first and last one?
Just had a hunch.
A hunch?
Yeah.
What's your hunch?
Would be it would be that if you so for age, if you use 16 and 20, that would give you a middle number, right?
All right. Well, you probably forgot about. Remember we talked about interpolation?
Sounds familiar.
Interpolation says you should pick what?
I don't remember what it means exactly.
It means you have to pick inner points.
Inner points. Okay.
You pick the first and last point.
Yes.
They're not inner points. They're outer points.
Gotcha.
So what you did is you picked the 2 worst order pairs you could pick. How do I know which are good points to pick? Make a scatter plot.
Yep.
See how the data is related.
Okay.
See the relationship graphically. So to make a stat plot, you go to second, y equals, turn the stat plot on. Make sure y is cleared out of everything. Go to stat, edit, type in the data. Clear that out, clear out L2. Type in your data, so 16, 17, 18, 19, 20. L2, 56.8, 61.3, 72.0, 4, 81.4. Turn my data.
Mm-hmm.
So to plot, since I turn my stat plot on, now to plot it, go to zoom, stat, which is number 9. There's my stat plot.
Yeah.
Now, based upon this, you know, which data points do you think are going to be pretty good? I want to find a line that comes as close to all of these as possible. All right.
Gotcha.
So,
Would you Oh,
You're
sorry.
eyeballing it basically. Which two do you
Yeah.
think will do the best job?
It would be the second point and the second to last point.
So you're saying these two? So those two will make a line like this. So I mean that, yeah, we could do that. That looks like it would work nice. Yeah, we could do that. So the second and the fourth one.
Mm-hmm.
All right. So that's this ordered pair and this ordered pair. So that's 17, comma 61.3, 19, comma 79.4. Those are my two ordered pairs that you picked. So find the equation by hand. Find the slope. Y2 minus Y1 over X2 minus X1.
So it would be 79.4 minus 61.3,
Mm-hmm.
and then 19 minus 17.
What does that give me? So I got 18.1 up top over what, 2?
Yep.
That gives me a slope of 9.05. Now, to find the equation of the line, right? Y minus Y1 equals M times X minus X1. That's the point slope form, right?
Yeah.
So I could use one of these ordered pairs. I'll pick the first one. Make sure you pick from the two you used, all right? And the slope. So Y minus the Y coordinate there is 61.3 equals the slope, which is 9.05 times X minus 17. .05 times X, and 9.05 times 17 gives me 153.85. So add 61.3 to both sides. And you're going to get Y equals 9.05 minus, so minus 153.85 plus 61.3 gives me minus 92.55. So that right there is the equation of this linear model that you found by hand. So if I want to use function notation, right? Ooh, I missed the X there, right? Yeah.
Oh, yeah.
So if I want to use function notation, or if I want to write this using the variables A and P, it's going to be f at A equals 9.05 times A minus 92.55. That's a 5, that's a 5. So you can pop that in your calculator, and Y equals, so 9.05x minus 92.55, and graph it, and there's the linear model that we found. There's the linear model that between the second and fourth ordered pair. Now, I mean, it does an okay job. but it doesn't really do the best job. So in letter B, what's that asking?
Find the linear regression equation using your calculator and
Yeah.
function notation.
Mm-hmm. So you got to, we do that using the calculator. So you go to math, stat, over to calc, and then you go down to number 4, which is lin reg. Hit enter there, and then go down to calculate. If you have a TI-84, you just go down to calculate. If you have a TI-83, if you look at the notes when we did this, after you hit lin reg, you type L1, L2, then hit enter.
Okay.
And you get, so there's the linear regression equation. So y equals ax plus b. So the line of best fit using function notation is f at a. The slope here is what, 6.73?
Yeah.
Times a, and the y-intercept b is negative 50.96. That's it. Just read it off in the calculator. And if you type that in y equals, so let's look at y2. Let's see how much better this is. 6.73x minus 50.96. So when you graph that, oh, look how much better that is.
Yeah.
That comes as close to all the ordered pairs as possible. You can't get any better than that one. Letter C. Now I'm going to find the A-intercept. So I'm going to use the line of best fit because that's the best model, right? Obviously, you're going to use the best model you got. So find the A-intercept means you're finding the value of P, right? You want to find P when, I'm sorry, I screwed that up. You want to find the value of A when P is 0. The other variable is 0. When you're finding the A-intercept, you're trying to find A when the other variable is 0. So since the function is equal to P, right? The dependent variable is equal to the function, f equals f of a, P equals f of a.
Right.
You're going to set this equal to 0. And solve for a. Add 50.96 to both sides. .73 a equals 50.96. Divide both sides by 6.73. So a equals 50.96 divided by 6.73. That gives me 7.57 if I round it to 2 decimal places. So my A-intercept is 7.57, 0. What does it mean in this situation? All right, this is the ordered pair A, P, right?
Mm-hmm.
A, P. So 7.57 represents the value of A when P is 0. So what does that mean? What does A represent in this problem?
It represents age.
The age of teenagers who have a driver's license, right?
Yep.
And P represents the percentage of the teenagers.
Yeah.
So what this is saying is, now how you interpret this, what I like to do is say like the dependent variable, the independent variable, that's what I do. So the percentage is 0. So what I want to say is there 0% of teenagers, or of US teenagers, right? 0% of U.S. teenagers at age 7.57 years have a driver's license. Right? You could also say 0% of U.S. teenagers at 7.57 years of age have a driver's license. You could say that as well.
Mhm.
Now, does that make any sense?
No.
I think it's very unlikely that someone roughly 8 years of age has a driver's license.
Right.
Now, I mean, I don't know. I don't work at the DMV. I guess it's possible. I don't know. I would really doubt it, but no, you're not. That's not a possibility. So this actually does make sense because this is saying no teenagers of age 8 years have a driver's license.
Right.
So that is a plausible result. That does make sense. But that's not to say that, I don't know. I don't know what the laws are. I don't know if that's possible or not. So I guess if that is model breakdown or not, I guess that just depends. I don't ask if it's model breakdown. I would, if I asked you it's model breakdown, then look at that. But if I don't ask, then don't worry about it.
Okay.
I think there's still 2 parts to this question.
Yeah.
Letter D. Estimate the percentage of 21-year-old adults who have a driver's license. So what I'm doing here is I want to estimate P, right? I want to find P when A equals 21. So that's easy. Just plug in 21 into your function. So F at 21 equals 6.73 times 21 minus 50.96, which equals 6.73 times 21 minus 50.96 gives me 90.37. So roughly 90% of 21-year-olds in the U.S. have a driver's license.
Okay.
Letter E is estimate at one age. So you want to find T, right? Or I'm sorry, find A. You want to find A when all drivers have a driver's license. So what percentage does that represent? If it's all.
100%.
100%. So find A when P equals 100. So what you're going to do here is you're going to set the model equal to 100 and solve for A.
Okay.
So 6.73 times A minus 50.96 equals 100. Add 50.96 to both sides. 6.73A equals 150.96. Divide that 6.73 by both sides. A equals, so 150.96 divided by 6.73 gives you 22.43. So according to that model, roughly 22 and a half years of age is when all adult drivers will have a driver's license. Now, if I asked if that was model breakdown, that would be an example of model breakdown because not everybody who's 23 has, or 22 or 23 has a driver's license.
Correct.
There are some people that don't have driver's licenses, so that, you know, for a number of reasons. So that's how you would do one of those questions on the test. You just got to know what variable it is you're looking for. Are you looking for the independent variable or the dependent variable?
Yeah.
If you're looking for the independent variable and given the dependent variable, you're going to set the model equal to that and solve for the independent variable. If you're trying to find the dependent variable, then you just plug in the independent variable into it and see what you get.
Okay.
That's why you have to know which variable is which, so you know what to look for.
Mm-hmm.
Otherwise, I can't tell you how many times, like for, not for D, but for letter C, I can't tell you how many times I've seen students plugging in 0 into this and getting negative 50.96. That's not what you do here. That tells me you don't understand which variable is independent and dependent if you do that.
Right.
I can't tell you how many times I see that.
For part B, you showed me how to do that through the calculator.
Mm-hmm.
If I do it without the calculator, like just doing it by hand.
You can't find the linear regression equation by hand.
Gotcha.
You could find a random model by hand by picking 2 random points, but you can't find the line of best fit by hand.
Gotcha.
Not in this class, anyway. You have to use your calculator to find the linear regression equation.
Okay. Number 8. With that one, with substitution and elimination method.
Mm-hmm.
You said what was it? You said that you could do either method for a problem like this, but one method would be easier than the other, correct?
Mm-hmm.
So for something like this, would it be like elimination method?
Yeah.
Okay.
Yeah, I would advise elimination method there.
It's that when you have just X and Y, then you could do substitution, right? Like that's when it'll be easiest.
Well, it depends on what the system is. If you have X or Y like by itself, then it's already set up for substitution.
Okay.
I don't have that here. So here you just use elimination. Like,
Gotcha.
I've seen students that will torture themselves with the substitution method.
Yeah.
Because if you use substitution here, you're going to get fractions, and you're going to get an ugly, ugly equation. But if you use elimination, it's so much easier. It's so much easier.
Okay.
If I solved one of those equations for X or Y and then plugged it into the other one, I'm going to get an ugly equation. Possibly. Okay. I don't want to take that chance. I want to do something that's easy. I know you do too.
Mm-hmm. Gotcha. Yeah, no, because that was the one question that I had. I forgot.
Do you want me to do this one or what?
Sure. Yeah, just to see.
So what variable do you want to get rid of, the X or the Y?
Dx.
So what am I going to do to the equations?
You're gonna plug in.
Well, you're not going to plug in something. You're going to do what to them?
So.
How do you use elimination?
You have to multiply, is it?
Yeah. You have to multiply the equations by a number.
So you'd have to multiply the top equation by a number from the bottom equation.
Well, it doesn't matter what the number is, just as long as that when you add the equations together, the variable cancels out.
Yeah.
So you want to pick a number that when you do that, the variable cancels, it goes away.
Okay.
So based upon that, what are you going to multiply the equations by?
Thinking. So I have to multiply one of the equations by a number that'll cancel out the x.
Correct. So, you know, to give you an idea what would work there, what is the coefficients in front of the x's? 3 and 7, right?
Yes.
So what's 7 times 3?
14.
No, 21.
Oh, 21. I'm thinking 7 times 2.
That's all right. So I know that 7 and 3 have a common factor. Well, they have a common product of 21.
Yes.
So I want one of the equations to have 21x, and I want the other equation to have negative 21x, right?
Okay.
Because when they add together, they'll cancel out.
Yes.
So what am I going to multiply the first equation by and the second equation by to get that?
Gotcha. So the first equation, you'd multiply it by 7, and then the bottom equation, you'd multiply it by 3, or negative 3.
Correct. That's correct. So let's do that. So 7 times the first one, negative 3 times the second one. So when I do that, I'm going to get 21x come on, camera. Negative 35y equals 70. And negative 21x minus 6y equals, what's negative 3 times 37?
Negative 111.
Yep, negative 111. Now add the equations together.
So then the 21s cancel out.
Correct, that's what you wanted.
Yep.
So now you have negative 35y plus negative 6y is negative 41y.
Yep.
Which equals 70 minus 111 is negative 41. Hey, look at that. Divide both sides by negative 41. Y equals 1.
Yep.
How do you find x?
You plug in 1 for y.
Into either the first or second one, doesn't matter which one, because they share that ordered pair in common. So
Okay.
you plug that into the first one. So 3 times x minus 5 times 1 equals 10. 3x minus 5 equals 10. Add 5. 3x equals 15. Divide by 3. X equals 5. So my solution set is the ordered pair 5, 1.
And then number 9 is,
What are you doing there?
you'd have to do elimination method as well. Or no. You could do substitution because the t's by itself.
Okay. So what am I trying to figure out there? What's the question that's being asked?
The winning times in seconds, WT and M of, or W of T and M of T for women and men, respectively, in Olympic 500 meter speed skating are modeled by the system. So then so we need to find out what will the timing be for when the women's winning time be the same as men's winning time?
All right. So what is that? This question right here is asking what? When will their times be the same?
Right.
So how do we do that? That means we set what? We set the two equations equal to each other, because that's what we're trying to find. All right. When will the women's time be the same as the men's winning time? When W of t equals M of t, and solve for t. And then to answer the second question, what will that winning time be? Once you find what t is, you plug it into either the first or second equation, because that'll be the mutual winning time.
Mm-hmm.
So set them equal to each other. So negative 0.153t plus 43.19 equals negative 0.135t plus 39.64. Add the t's to both sides. Subtract the 43.19 from both sides. They cancel. They cancel. So negative, so be careful with that. Just be careful with the decimals. So negative 0.153 plus 0.135 gives me negative 0.018 t equals 39.64 minus 43.19 gives me negative 3.55. So divide both sides by negative 0.018. So t will equal negative 3.55 divided by negative 0.018, which gives me 197.2. So what does t represent?
Yeah.
What does it say right here?
Is T's the number of years since 1970?
Yep. So that's 197 years after 1970. So 197 plus 1970 is the year 2167. So when will the winning time be the same as the men's winning time? In the year 2167.
Mm-hmm.
So they'll be the same in the year 2167. Now, what will be their mutual winning time? How do I do that?
Would you plug 2167 in for T?
No, you don't plug 2167 in for T. You plug in what you found for T originally.
197.2.
Yeah. So 197.2, you're going to plug that in for X or T or whatever. I'm doing it in my calculator. So 197.2 I'm storing in for X. And then I could type that into, I could type the first equation or the second one. Doesn't matter. I'll type the first one. So negative 0.153x plus 43.19 gives me 13.0184. So I just plug that into, let me write that over here. So I just evaluated the woman function at, what was it, 197.2 equals negative 0.0153 times 197.2 plus 43.19. That's what I just did in my calculator. And that gave me 13.02. So in the year 2167, they'll have the same winning time of 13.02 seconds.
Yeah.
That's it. That's it.
So we don't have to. Okay, no, never mind.
Alright, that's fine.
Yep. I'm looking at number 12, and for part C, I see before the square root sign, the power of 4.
Yeah, that's an index of 4. So that pertains to the content we would have seen in chapter 9.
Gotcha. Okay.
In order to perform this operation, you could just, you could make use of this property right here. We worked with square roots.
Yes.
But in general, you could work with any kind of root in the same way. It doesn't matter if it's a cube root, a fourth root, a fifth root, it doesn't matter. All right. So we know this property from square roots. When we did quadratic equations, we know this, right? That's a square root.
Yep.
That's when you have actually a 2 there, you just don't see it because that's a square root. That's true for cube roots, fourth roots, and so on. So when I do this, I could just write this as the fourth root of 9x to the fourth power. But now everything under here, this needs to simplify by looking at everything in here in the radicand, okay? If there's anything to the fourth power, or if I have a perfect fourth root, it would simplify with the fourth root. So if anything down here could be written as a fourth power, a perfect fourth power, that'll cancel out with this fourth root.
Okay.
Well, there is no number raised to the fourth power that would give me 9, right? How we like perfect squares and perfect cubes? Numbers that are raised to the second power, to the third power, and so on. Well, perfect fourth powers would be 2 to the fourth, 3 to the fourth, 4 to the fourth, and so on, right? 2 to the fourth is 16. 3 to the fourth, that's 9 times 9, which is 81. I don't even know what 4 to the fourth is. That would be 4 times 4 times 4 times 4. That's 16 times 16, which is what? 256. So these numbers are perfect fourth powers. 9 is not a perfect fourth power. So I'm just going to keep that as the fourth root of 9. But x is raised to the fourth power, isn't it? You can see how x is raised to the fourth power?
Yeah.
And I'm taking the fourth root of something raised to the fourth power. So they cancel each other out. And I'm just left with x.
Gotcha.
X to the fourth power, and then you take the fourth root of that, they cancel each other out. You're just left with x to the first power. And that's it.
Okay.
What about you, Zandria? You're being awfully quiet. Are you there, Andrea?
Yeah, sorry. I'm following along.
You're following along? Okay, don't be afraid to ask anything if you want. You got 1 more hour for me, or unless you don't, I prefer to, I'm exhausted.
I understand that. I've been up. Oh God, I've been going to bed at 6 a.m. the last few nights. Just
6 a.m.?
yeah.
Sleeping all day?
Well, I wish. I'm going to bed at 6, waking up by 11. Unless, well, this week I had class at 9 a.m., so I was waking up by 9. And it's kind of like get as much done as I can.
Yeah, I was up till 2 in the morning recording video lectures.
Wow.
And then I have to upload them to Canvas, and then I have to grade tests. Then I have to write my final exams. Then I'll have to grade those next week, and then I'll have to upload my final exam grades.
Yeah.
So I have a full plate myself.
Yeah. It's gotta be annoying and tedious doing the grades and all that for our tests that we do on paper.
Yeah, well, I mean, some students don't bother answering every question, so sometimes grading them can be kind of fast.
Yeah.
If you catch my meaning. Do you have any other questions on this thing that you want me to go over?
Not that I see. Number 14, is that also part of chapter 9?
Number 14. One. You talk about letter B?
Yep.
It is, yes.
Okay. So I'm looking, I was like, I don't think I've seen that before.
No, you haven't. That's a radical equation.
Okay.
So to solve a radical equation, you need to isolate the radical on one side. So I'm going to subtract 1 from both sides. So I'll have the square root of 2x plus 5 equaling 2x minus 1. Now, since the square root is isolated, now this is a square root. So how do I get rid of a square root? What am I going to do to both sides? To get rid of the square root, I'm going to do what?
Have to. Oh.
You square it.
You square it. Yeah. So you square it. Right. So when you square the square root, they cancel each other out. So you're going to be left with what on the left side? Or you're just going to be left with 2x plus 5 on the left side. The square root and the square will cancel each other out. Now the right side becomes 2x minus 1 quantity squared. So now what I got to do is I got to combine like terms. So 2x plus 5, I have to FOIL this out. All right, I got to FOIL that out. That's 2x minus 1 times 2x minus 1. I got to FOIL that out, so I'll get 4x squared minus 2x is minus 4x. Minus 1 times minus 1 is plus 1. All right. Let me bring the 2x and the 5 over to the right. So I'll have 0 equals 4x squared minus 4x minus 2x is minus 6x. 1 minus 5 is negative 4. So let me rewrite this. It's 4x squared minus 6x minus 4 equals 0. You with me so far?
Yep.
Okay. You're just combining like terms, right? You're foiling out combining like terms. So does this factor? Can I factor anything out of that? It's a quadratic, isn't it?
Yep.
Can I make it simpler?
Yes.
There's a 2 in common, isn't there? A GCF of 2.
Mm-hmm.
Pull it out. So I'll have 2x squared minus 3x minus 2. Now what I could do is divide both sides by 2 to get rid of that 2. Because the right side is 0, so 0 over 2 is still 0. So now what I have is 2x squared minus 3x minus 2 equals 0. That's a quadratic equation. How do you solve it? Preferably, you want to do what? You should always make sure that your quadratic can what?
Can factor.
Factor. So let's try factoring it. If it doesn't factor, then we'll just go from there. So my leading term is 2x squared, so I have an x and a 2x. And I'm either going to have a 1 or a 2, or a 2 and a 1. So which one is going to work here? I'm just doing the AC method really quickly here, right?
Mm-hmm. So it would be,
I think the 2 is going to go with the x, and the 1 is going to go with the 2x. So, because that'll be 2x, or what, this will be x, that'll be 4x, and that gives me negative 3x, right?
mm-hmm.
So that'll be negative there and positive there. All right. All right, so it does factor, great. So that means x minus 2 equals 0, or 2x plus 1 equals 0. Add 2 to both sides, so you get x equals 2. Subtract 1, 2x equals negative 1, divide by 2, x equals negative 1 half. Now, when you're doing a radical equation, you have to check your solutions. So let's do that in the calculator. So store 2 in for x. Type in the original equation. Type in the left side and the right side. They should get the same value, right? If it works. 1 plus the square root of 2x plus 5. That gives me 4. And then 2x is also 4. So 2 works. All right. Let's try negative 1 half. Negative 1 divided by 2, store that into x. Type in the left side again, 1 plus second square root 2x plus 5. That gives me 3. Type in 2x, I hit enter. Uh-oh, that gives me negative 1. They're not the same, are they?
No.
So negative 1 half doesn't work. So that's not a solution. So the only solution is 2.
Okay.
Anything else?
I'm looking.
What about this one? Letter A.
Okay.
That's solving a rational equation. So to solve a rational equation, you got to do what? You got to find the least common denominator.
Yes.
So multiply the denominators. 5 times x plus 1. So 5 times x plus 1 is the LCD. Multiply both sides of the fraction by the LCD. So 5 times x plus 1 times the left side equals 5 times x plus 1 times the right side, which is just 1. So when you do that, what happens? Distribute the 5 times x plus 1. What happens here when you distribute this? So here. What happens to the x plus 1s?
They cancel out.
Yep. So I'm just left with 5 times 3.
Yep.
Plus, now distribute 5 times x plus 1 to 2/5. What happens there?
Would the 5 cancel out?
The 5s cancel out. So you're left with 2 times the quantity x plus 1
Mm-hmm.
equals 5 times x plus 1 times 1 is just 5 times x plus 1. Now that's a nice linear equation. So 15 plus distribute the 2, so it's 2x plus 2. Distribute the 5, 5x plus 5. 15 plus 2 is 17, plus 2x equals 5x plus 5. Subtract 2x from both sides. Subtract 5 from both sides. So you're going to get 3x equals 17 minus 15 is 12. Divide by 3. So that means x equals 4, right? So my solution set, now you have to be careful here, okay? If I look at my original equation, what if I plug -1 in here? What's going to happen?
So if you plug in -1,
What's going to happen?
it wouldn't cancel out because you have x plus 1 under 3 still.
What's -1 plus 1?
So it would be
If you put -1 in this equation, what happens?
it would be 0.
You get a 0 in the denominator, don't you?
Yep.
Can you do that?
No.
No. So that means x equals -1 will not work.
Gotcha.
So if you were to solve this equation and you got -1, then your solution set would be no solution because it doesn't work.
Okay.
But since I got 4, that's okay. My solution set is 4.
For number 6,
Number 6. Okay.
would I have to subtract the x and subtract the 5?
Which one are you talking about? Letter A?
Yep, letter A for number 6.
Mm-hmm.
Would I have to subtract the x and the positive 5, move it to the other side?
Correct.
Okay, gotcha.
That's correct.
And then it would equal 0.
Then factor it.
Gotcha,
Set each factor equal to 0, solve for x.
gotcha. Um, with the first problem we did about we did number 7. Will we see a lot of problems like that on the final, or just a few?
The data one with the
Yeah.
model?
Yep.
You could see a problem like that on the final, yeah.
Okay.
Yep, you could, definitely. And you could see one like the winning times for the men and women race. You could see a problem like that too.
Gotcha. Number 11. Could I see how we do number 11?
So just solve the linear inequality.
Yeah. So we would have to do -5 times 2, and then
Just get x on one side by itself.
okay, gotcha.
So distribute the -5 here into those. So when you do that, you get -10x minus 20 plus 1 is less than or equal to 3x minus 3. So I have what, -10x, -20 plus 1 is -19, less than or equal to 3x minus 3. I'm going to subtract 3x from both sides. I'm going to add 19 to both sides. They cancel. They cancel. So I have -13x is less than or equal to what? -3 plus 19 is 16. Is my math right?
Yep. Yep.
Divide by -13. Now, if I divide by -13, what happens to the inequality?
You have to flip the sign because it's a negative.
Correct. So less than or equal to becomes greater than or equal to -16 over 13. So on a number line, right? If I were to put -16 over 13 on a number line, this means it's everything to the right of it, right? So everything shaded to the right, including -16, 13, because it's greater than or equal to.
Mm-hmm.
And in interval notation, it's the smallest value up to the largest value. So -16 over 13, comma, infinity. Infinity is open, and since -16 over 13 is included, it's closed. That's the interval notation.
Okay. And then the bracket, you have to put the bracket over the number you get, right?
I'm sorry, say that again.
The bracket that you put next to the -16/13,
Mm-hmm.
you have to put that next to the number you get all the time, right?
That's, you put that when it's part of the interval.
Okay, gotcha. And then if we turn it into a decimal, would that be fine or would that be wrong?
Just leave it as a fraction. The only time you're going to use decimals is when you're doing linear modeling.
Okay, gotcha. I think that's it for me.
Yeah?
Yeah.
What about you, Zandria?
I think I'm good.
Yeah?
Actually, for number 5, um,
Yeah?
it would be y minus y1 equals m plus x minus b.
No. You're close, but no. Y minus y1 equals m times x minus x1.
Um, Gotcha. Yeah, that's it for me.
Is that your final answer?
Yes.
Okay. Well, I mean, I was going to go to 3 o'clock, and if you're fine, that's fine with me. I'm surprised there was only 2 of you. I really am.
Yeah.
I guess everybody else was just too busy, or I don't know. It is a Friday after all, and a lot of students work
Yeah.
funny schedules. So. But I'm sure there's also a percentage of them that just, you know,
Just didn't want to show up.
I guess. I hate to say that, I guess. But, you know, it's, you know, I'm not, it is what it is. I mean, there's a lot of things. I don't speculate. So are we done?
Yeah.
Are we done, guys?
I don't have any more questions.
All right. Well, thank you for coming.
Yep. Thank you for going over this stuff with us.
I'm going to post this on Canvas, this video review, because I am recording this.
Gotcha.
Like I said, I would. So.
Mhm.
All right.
Yep.
All right, guys. Well, yep. We'll see you during the final. Don't forget to finish up your homeworks between now and then. So.
The final's on Wednesday at 4 p.m.
4:30 for you, Brendan.
4:30.
Zandria, for you, it's going to be. Zandria, you're in my Tuesday, Thursday section, so your final exam's at 8:30 on Tuesday. It's in that email I sent you.
Oh, okay. Gotcha.
Check your email.
All right. Yep. Yeah. Thanks a lot. I appreciate, you going over this.
Yep, no problem.
All right. Well,